Hey, I'm Courtney Waterman, your tutor. Lover of anime, manga, and math. And you just tuned into another session of Tutor Me Sempai. Welcome back, everyone. Today we're jumping into a 10th grade topic, basic trig ratios. If you're new to my channel, I'll be putting time codes in for this video in the description box below, so use that to skip ahead to whatever part of the video you think is most interesting. If you have any question about what you see here today, or even your own homework, remember you can always put them in the comment box below, or visit me on my Facebook page at Tutor Me Sempai and tell me all about it there. When you find this video helpful, remember to leave a like. It really helps the channel. And while you're at it, hit the notification bell, smash the subscribe button, and share this video with a friend. Well, without further ado, let's talk a little bit more about these basic trig ratios. So the first thing you have to talk about whenever you're talking about these basic trig ratios is how does this triangle look? You have to know what your triangle is going to look like. So the first thing we have to do is draw a triangle out. And we need to have a special type of triangle. We need to have a right triangle for the basic trig ratios that we're going to be covering in this video. Now there will be other trig ratios, and that's going to be for another video, but we're just going to talk about the basic ones, and that is what you're going to need a right triangle for. So the first thing we draw is a right triangle. So the next thing we're going to have to do is label the sides. So we're going to have three different types. We're going to have an opposite side, we're going to have an adjacent side, and then we're going to have a side called the hypotenuse. So those are the three different labels we're going to be giving, and I'm going to give them shorthand O, A, and H. So I have to keep writing that out. So there's going to be an opposite side, an adjacent side, and a hypotenuse. And we're also going to have an angle. So we're going to label our angle in such a way with a theta. So we have a right triangle, we have three sides, opposite, adjacent, hypotenuse, and we're going to have an angle theta. So now we have all the makings. Let's put everything together and let's find out what our triangle is going to look like. So let's pick an angle. This is already a 90-degree angle since it has to be a right one. So one of these two is going to be theta. So I'm going to put theta here. And that's important because this theta is going to dictate what our opposite and our adjacent is going to be. Hypotenuse is always 100% of the time going to be the longest side of the triangle, which is always going to be opposite the right angle. So this is going to be our H. So you don't have to think about that one. As long as you know what your right angle is, you go opposite that. Whatever line is going to be on the opposite side of our right angle is called the hypotenuse. Since we're focusing on this angle, we're going to talk about what's opposite this angle and what's adjacent to this angle. If the angle switches, opposite and adjacent will switch, and I'll show you that later. But for right now, our theta is here, so we're going to figure out what our opposite side is and our adjacent side is in respect to this focused angle here, this theta that we're looking at. Opposite, just like we did an opposite for this right angle, which we pretty much just drew a straight line away from this angle, we're going to do the same thing here. So you draw a straight line, and you see that this side is going to be our opposite of our theta. I can't stress that enough. This is not always going to be opposite, but it's always going to be opposite to this theta. Adjacent. Adjacent just means right next to, right? So which side is next to our theta? And it's not the hypotenuse. Remember, the hypotenuse is always the longest side. So you don't have to worry about, well, there's two sides next to our theta. No, our hypotenuse is always going to be the longest side. So that's always going to be H. So the other side that is next to this is going to be called the adjacent side. Let's say we had an angle X here. So instead of having angle theta like we had here, let's say our X is here. Our angle is X here. And you notice it's the same type of right triangle, except we put our angle up here, and we're going to focus on angle X this time. First thing we do is find our hypotenuse, which is always going to be opposite our right angle. So we're going to put that there. Now, we're no longer focused on this side. We're going to focus on this. So I actually need to get rid of this angle X here. Let's put it up here so we can kind of keep track that this is our angle X triangle. This is our angle theta triangle. So we have our angle X up here, and opposite that one is now going to be down here. So you see how the O is no longer here like an angle theta triangle. We're going to have our O down here, and adjacent now looks right next to it. so that's going to be A there. So we have two triangles that are pretty much identical as far as how they look from the outside, but based on where your angle is, you're going to have different opposite and adjacent sides. So angle placement, very important. Wherever your angle is, that's going to dictate these two. Hypotenuse is always going to be the longest side, and it's always opposite your right angle. And we're going to be focusing on right triangles when we're talking about the basic trig ratios in this video. So now that we have our right triangle in which we can set up our three sides and our angle, let's talk about our trig functions, which are going to help us identify our trig ratios. So we're going to have a sine function, which is going to be sine of whatever angle we're talking about. Because we have theta in our graph here, I'm going to use theta here. We're also going to have a cosine theta, and I'm going to put a tangent theta all the way up here. So we can use these three trig functions to tell us something more about our triangle when we're giving some information but not everything. And we do that with our ratio. So we have a ratio assigned to each of these trig functions, and they're going to be using what we just talked about: the opposite sides, the adjacent sides, and the hypotenuse side. So the ratio for the sine is going to be the opposite side over the hypotenuse side. So the ratio for the cosine function is going to be the adjacent side over hypotenuse side. And the ratio for the tangent is going to be opposite side over adjacent side. So what does this mean for this triangle here? Now remember, we're going to be focusing on theta, and theta is going to dictate which sides are opposite and adjacent. So because our theta is here, we know that this is going to be our opposite side, so I'm going to put an O here. This is going to be an adjacent, and this is always hypotenuse because it's opposite our right angle. So when we rewrite this as sine of theta equals, well, what is the opposite side's length? Well, the opposite side is over here, and we have a length of 3. So we're going to write that as 3 over hypotenuse. The length of the hypotenuse is 5. So we have 3 over 5 for this sine theta. This is our ratio here. How about cosine? Cosine is going to be adjacent over hypotenuse. Well, we're going to focus on theta again. And what's the side adjacent? That's going to be here, and that's going to be a 4. So we write this as cosine theta equals 4 over same hypotenuse, 5. Now tangent is a little bit different because we're not going over hypotenuse, but we still have the other sides. So we're going to rewrite this tangent theta as opposite. Remember, we're still focused on theta here. Opposite, which is 3 over adjacent, which is 4. So these are the basic trig ratios that's going to be able to help us determine a little bit about the graph when we have some information but not all the information. So how can we easily remember our basic trig ratios? As you can see, it's probably going to be very easy to confuse what the sine ratio is and the cosine ratio is. Well, that's where we come in with SOH CAH TOA. That's going to be a nice, easy way to help us, and it's a very famous way. You may have even heard it already. SOH CAH TOA is what we use to keep everything in order. So how is SOH CAH TOA going to help us remember our basic trig ratios? Well, let me tell you, this is exactly what we need because this is our roadmap, our blueprint for remembering the order. It tells you everything you need to know, and the first part of that information is the trig function. This first letter is exactly what you need to tell which trig you're focusing on. This S means you're going to focus on the sine here, and remember, each of them are going to be focused on a theta, some kind of angle. It could be sine X, it could be sine Y, but in this case we're saying sine theta for our angle. This is going to be cosine, so we have a cosine theta, that's C, and this is going to be tangent. So we have a tangent theta for that T. The last two letters are going to tell you not only these sides, but the order of the sides. The first one goes on top, and the second one goes on the bottom. This is an O, so that's opposite, and that's your H, so hypotenuse. So this is going to be opposite over hypotenuse. This is an A, so that's an adjacent. And this is, once again, an H for hypotenuse. And this is an O, so opposite, and that's an A, so adjacent. So you see, SOH CAH TOA tells you exactly what you need. This is our roadmap. If you can remember anything from this video, remember SOH CAH TOA tells you how to set up your basic trig ratios. That's your trig function, that's your top side, that's your bottom side. That's your trig function, that's your top side, that's your bottom side. That's your trig function, that's your top side, that's your bottom side. SOH CAH TOA. So our question today is to find our missing side x. We're given two things, our angle and we're given one side, but we need to find our missing side x. And we're going to use SOH CAH TOA in order to do this. So let's write out SOH CAH TOA and figure out which part of that is going to help us exactly find this missing side. So SOH CAH TOA reminds us that our sine is going to be opposite of our hypotenuse, our cosine is going to be adjacent over hypotenuse, and our tangent is going to be opposite over adjacent. So looking at what we have here and what we're trying to find, which one is definitely not what we're going to need? Well, if you look, we have this over here, which is one side, but what is that? If our focused angle is this 36, what is this? Well, this is going to be our hypotenuse, right? That's always going to be hypotenuse because it's opposite our right angle. So it didn't matter what our angle focus was, we're always going to have this hypotenuse, our longest side. So we need some form of hypotenuse in our ratio. That means tangent is not going to help us here. We're either going to be doing sine or cosine. Now looking at what we have, what side is this that we're trying to find? Is that going to be opposite or adjacent? Remember, our angle is 36. That's the angle we're focusing on all the way up here. So what is this when we compare it to this? It's going to be opposite, right? We're going to go opposite this angle and find this side here, which is our x. So we need opposite and we need hypotenuse. So we don't need cosine. So sine is what we're going to be using for this question. So let's rewrite this sine with, instead of theta, our actual angle, 36 degrees. And that's going to equal opposite over hypotenuse, which we know opposite is x, and hypotenuse is 13. Now we have to find x. So what do you got to do in order to solve for x? Get x by itself, right? So we're going to get x by itself by multiplying both sides by 13. So that's going to mean that x is going to equal 13 times sine of 36 degrees. Now, if you have your calculator, you can plug this in. If they want you to keep this without rounding, you can just kind of write that and leave it. This will be your answer, x equaling this. But if you want to find what this is in decimal form, you can plug this into your calculator, sine of 36, but make sure that your calculator is in degrees because this is going to be degrees here. This is 36 degrees. So sine of 36 degrees times 13, that's going to give you what your answer is. So that's going to be 7.64. That's going to be our missing side. X is going to be 7.64. So if you want to keep it without rounding, that's what you have. But if you put this in your calculator and round it to the nearest hundredth, you get 7.64. So I hope you are following today's example, and I hope that SOH CAH TOA is going to be just what you need to remember your trig ratios. If you have any question about what we saw today, remember you can put them in the comment box below. I'd love to be able to help you as much as I possibly can. However, if you have questions about your own homework and below is just a little bit too small, visit me on Facebook, on my Facebook page, @Tutor Me Sempai, and tell me all about it there. If you haven't done so already, remember to leave a like, hit the notification bell, smash the subscribe button, and share this video with a friend. Well, that's all the time I have for today. I'm really hoping this helped with your homework, and I'm looking forward to seeing you again next week. I'm Courtney, and this is another session of Tutor Me Sempai.